Hey guys! So, today we are going to talk about performance. So let's get into it. You see, performance is one of those little things that it doesn't matter until it does. Now, what do I mean by that? Why am I so cryptic? Don't worry, I'm gonna explain. So yesterday I was tasked with having a look at a little bit of an issue that we have in my company, because a few days ago we started noticing something. We started noticing from our very fancy instruments and tools and monitoring and all that good stuff and all our nice graphs that shows us the health and the loads and the CPU usage and the memory usage and all those great things that we need in order to figure out if the running system is actually working correctly. We started noticing something. One of our core features, well, I'm not going to say one, the core feature, started failing for quite a lot of users. It just started failing. Our alert systems went off and we saw that the amount of failed requests was measured in hundreds of people to begin with. And usually that's around the time our stakeholders come in and ask, guys, what the hell is going on? Nothing's working. That's usually how it goes. They don't really because when we talk about these sorts of issues with them, when we're in the planning meeting and everything's working, we don't really have the same sense of urgency, but it gets really urgent when this happens. Go figure, right? Anywho, so my team and I, we kind of say, oh yeah, sure, we're on it, we already know. Started looking into it and everything kind of relaxes, and we figured out that, okay, this is a tricky question to answer. Why are we timing out all the time? Because that's the thing we could narrow down. We could see that there was a latency issue. We could figure out that for some reason, the computation simply takes too long. And that's not a fun position to be in when something takes too long. And this is what I've been telling the people who are talking about. Guys, when you get to a certain size of company or a certain size of application, certain things starts to matter a lot more than they do when you create your own hobby project. This is one such instance, because a hobby project does not have the sort of load and the sort of heavy computation that is required in order to produce the results that are needed for this. So you don't have to think about all these different things. But now that we are in this situation, we get to pull out one of my favorite tools, which is something that I use quite often, and that, my friend, is a profiler. A process profiler, call it whatever you want, but a profiler that allows us to basically go through the execution of the process. In other words, we monitor the system. We figure out where the hotspots are. So what do we call the hotspot? A hotspot is simply a piece of software or a piece of code or method in your code base that is running quite a lot and for a long time. And when we have that, depending on what you're using, I mean, in Node, I absolutely love it. There are some really, honestly, the Chrome team has done this really nicely. They have among my favorite profilers. It's really beautiful to be able to see how long each method takes in execution time and which methods are running for the longest, and burrow down in these details. And that's exactly what we had to do. And so we figured out that, there's this one method here that seems to be taking quite a lot more time. I mean, we have all kinds of other issues, but this one is standing out quite a lot. So we go down and we have a look. Okay, doesn't seem really weird. There's this method structure where we have a bunch of events that are happening, and then we sort them and we do a few mappings and we kind of transform the data a little bit, and at the end we filter out the stuff that we don't need, and then we return that in order to continue the computation. Now, how could we improve this? Well, it was actually kind of funny, because it all came down to us changing the order of the execution of this little piece of this tiny block. Because if you were listening to what I was saying, we actually sorted all these events before we did the mapping and filtered out the stuff that we actually needed. So by switching that order, in other words, we simply do a linear execution and we do all the transformations and all that good stuff, and we sort after we only have a subset of the thing that is actually coming in, we could actually improve that performance to a point where we got closer to our threshold. We're still not there, but we got closer. That tiny switch, that tiny little optimization meant a massive difference for the amount of users that could use our application. In other words, we went from having hundreds of failed executions to having maybe 100, 200 failed executions. We still had to continue working, but that tiny little change was the difference. Now, if you were working, and I mean the person who wrote this software to begin with, they never considered, most likely, or I mean, it's an easy mistake to make. Anybody could have made it, because you don't really think about that stuff when you're working. And we can argue whether or not you should have that mindset when you are working, that you should always think about these extreme, like these performance issues. Because by simply changing that piece of logic, it actually had a massive impact on our application as a whole. Because, as I've said to you guys, if that method that executed that piece of logic is running over a data set that is maybe, say, 100 elements, or say, let's go really high, 1,000, 10,000 elements, that's not going to be noticeable, even if it is inefficient, because the computer is simply so strong that it's going to be able to execute that, no problem. But when you have literally millions and millions of events, or in this case just events, happening for every single user, and you have hundreds of thousands of people using that one thing or on your system at the same time, it starts adding up, and it adds up quickly. So even that small change made a big difference. So right now we're actually going through all of the hotspots of this code in order to figure out how we can performance improve the different areas. Now, I'm not saying that this is something you should do ahead of time, but it is something that you should be aware of. So knowing about how to profile a system is really, really important to figure out where you're spending your time, and figuring out, okay, which methods are like being used quite a lot and are doing quite a lot of heavy computation, and how can we improve those. Right now I'm working on such a story where we have a feature request from our stakeholders that literally is going to it's going to be a performance nightmare. It is absolutely horrible. We're going to go through basically all the data and generate statistics. And statistics, guys, that's heavy computation. That's why I'm pair coding with my boss right now, my CTO, because we need to get this right. Because trust me when I say this, guys, generating something like statistics, it requires a lot of resources. So what I want you to take away from this is that maybe you don't have to think about performance all that much when you're first starting out and you're doing something small. But it gets really important that you understand how to profile systems and all that good stuff, and how to actually improve execution time. So big O notations and all that stuff that you learn in computer science class, it's not that important at small scale, but when you have a performance problem, it gets a lot more important. Have a great day.